Hi everyone, we are from the SA Consultants Sdn Berhad. The project title Proposed Design and Build 6-Story Building at Ibu Pejabat Lembaga Lebuhraya Malaysia, Wismah Lebuhraya, Kajang, Selangor, Darul Ihsan is a project where we to propose a proper design to a client for a building with 6 story. We are required to design a building by using STAAD Pro software as demanded by the client, Lembaga Lebuhraya Malaysia. Once the structure is formed, now we will add support to the structure at the base layer of the structure. The support that we will use is fixed support. Move on to the property page. Now we will assign the property of the member such as column and beam. For our structure, we will assign UB 1016 times 305 times 272 for the structure of beam, and for column we will use UC 150 times 372. In this phase, we will assign the property to the structure. First, we will assign the property to the beam. Second, we will assign the property to the column. In this structure, we will apply 3 types of load cases. In load case 1, we will apply 3 vertical load, which are self-weight, uniform distributed load, and slab load. We are assigning self-weight with a factor of -1.2 to the member of structure. Next, we are applying uniform distributed load from the node A1 to E1. Now, we will apply slab load in downward direction with the pressure 15 kN per meter square. In load case 2, we will apply horizontal load, which is wind load. This wind load will be in both direction of Z. The intensity of wind is 0.7 kN acting laterally full height of the building at both direction of the building. Load case 3 is the combination of load case 1 and 2, which are combination of vertical and horizontal. Now we are going to STAAD editor. In this editor, we will add perform analysis before the line of parameter 1. Don't forget to save it. After that, we can go for run analysis. In this analysis, we can check the error and warning. After we found some error and warning, we decided to change our property for beam and column. For beam, we change to UB 1016 times 305 times 272 in British Standard, while for column we use UC 200 times 46.2 in Australian Standard. So, why we choose this combination of material? After the run analysis, the combination of this material will not fail because the actual ratio does not exceed the allowable ratio of 1. In the meanwhile, we choose this material because it is nearest to the allowable ratio, where this can save the cost of material and the construction. Here in this unity check for load case 1, we will observe the critical member. So, why do we call these members are critical? It's because we are observing the actual ratio which are nearest to the allowable ratio of 1. In this unity check, no fail member, we have just a critical member. These are the member of maximum forces and moments in each direction of X, Y and Z. So, this will be the bending moment diagram for beam 4, beam 9, beam 82, beam 648 and beam 953. For unity check of load case 2, we will determine the critical member. So why we call this as critical member? It is because we will observe the actual ratio which are nearest to the allowable ratio 1. However, in this case, the actual load are less significant and far from the value of 1, which is 0.017. This will be the bending moment diagram for the beam 118, beam 338, beam 404, beam 410 and beam 499. For the unity check of load case 3, we will determine the critical member. From this table, we can observe that the value of actual ratio are same as load case 1. This is due to the insignificance of effect from the wind load that we combined earlier. In this case, there are no failed members. So, This will be the bending moment diagram for beam 4, beam 9, beam 82, beam 648 and beam 953. We have come to the end. Based on the STAAD Pro software, the structural design team project finished without any errors and warnings. The objectives of the project were achieved in the process of making this project a success. Thank you. See you again.